this video I'm going to talk through a couple of exact values that you really do need to remember. So first off, we're going to deal with some common angles. First off, 0 degrees is the same as 0 radian. Now 90 degrees is the same as pi on 2. So actually, let me just draw x, y. Let me draw these angles for you. So I'll put a circle here. So our angles, 0 degrees is obviously just flat out this way. 90 degrees is directly up. That's a 90 degree angle. So this is 90 degrees equals pi on 2. Now our next one along here is 180 degrees. 180 degrees. 180 degrees. And that equals pi radians. So 180 degrees equals pi radians along here. Next one coming directly down is 270 degrees. And 270 degrees equals 3 pi on 2 radians. Not surprising because it's the same as pi on 2 plus 180 degrees, which is pi. So it's pi plus pi on 2, 3 pi on 2. So 270 degrees is 3 pi on 2. And lastly, the one coming this way is, of course, 360 degrees. And that equals 2 pi radians. Okay, so there's the first lot of things you should remember, the ones that are these different quarters, if you like. Okay, some more angles that you should really try hard to remember. Firstly, 30 degrees is pi on 6. So 30 degrees comes out like that. So with 30 degrees, you know that you can split things. This is kind of poorly drawn, but if that's 30 degrees, then that's 30 degrees, and that's 30 degrees. So they make 90 degrees. And then there'll be another 3 of them in this one. Another 3 here. Okay, so 1, 2, 3, 4, 5, 6. So there's 6 slices. They all contribute to get pi. So pi on 6 is 30 degrees. So 30 degrees equals pi on 6. Alright, the next key angle is 45 degrees. So 45 degrees, I'll do this in a dashed line. Here it is. So this dashed line, 45 degrees. You know it's 45 because it's halfway of the 90. It's half of 90. So here's a bit neater, 45 degrees. It's just split down the middle, 45 degrees. And that equals, obviously it's going to be pi on 4 because it has to be half of pi on 2. So that's pi on 4 radians. And last one that we need to remember is 60 degrees. So 60 degrees is this bit here because it's 2 30 degrees. So 60 degrees here. Because it's 2 of 30 degrees, it's 2 of pi on 6. Therefore it's pi on 3. Okay, so there's a whole bunch of things to remember for you, and the more you use these, the more you will remember them. Right, there they are, a list of things to remember. It's probably a good idea to copy those down right now. Pause the video, copy those down. Okay, now what we're going to talk about is some exact trig values. So some key trig values that you should try to remember. We're just going to cover some of them because some other ones you'll get out of the unit circle, which will be in the next video. Okay, so some exact trig values. First, let me explain how we get them. Let's start with a square. Okay, and this square has a side length of 1. Now what I'm going to do is chop the square in half, and now I've got a triangle. So let's look at this. Bottom triangle is sides of 1. This hypotenuse here, well, let's use Pythagoras. The hypotenuse squared is equal to the other two sides. Let's call them the adjacent squared plus opposite squared. hypotenuse squared is 1 squared plus 1 squared, 1 squared plus 1 squared, which is equal to 1 plus 1, hypotenuse squared. So hypotenuse squared is equal to 2, so the hypotenuse is the square root of 2. Alright, so that side is the square root of 2. Now, because it started off as a square, this is a right angled triangle. And because it's a square, this angle here is the same as that angle. And it's also the same as this angle up here. So together, that and that is a right angle, 90 degrees. So if we cut it in half, that must be 45 degrees. Or 45 degrees is pi on 4. Pi on 4. So let me draw this a bit more neatly for you. Oh gosh, that's not very good. Let me just do another one. Alright, that's a bit better. So right angle, side lengths of 1, 1, hypotenuse root 2, and this is pi on 4, which is the same as 45 degrees. So is that, but let's not worry. Now, just one moment. Okay, so now we can find some handy trig values. So first let's find sine of pi on 4. Sine is the opposite over the hypotenuse. Opposite is 1, hypotenuse is 2. 1 on root 2. So sine pi on 4 is 1 on root 2. There's an exact value for you. Cosine of pi on 4, or 45 degrees, is adjacent 1 over hypotenuse root 2. So they are both the same. They're both the same. And tan of pi on 4. Tan of pi on 4, well, that's opposite 1 over adjacent 1 equal to 1 over 1, which is equal to 1. So here we go for pi on 4, 45 degrees. We've got sine and cos are 1 on root 2, tan is 1. Okay, so just remember, if you remember how to construct this triangle, you don't have to remember these. You can just draw a little triangle in the corner of your page, and you'll get all these values quite easily. Alright, next. Okay, so our next exact values we're going to get from an equilateral triangle. An equilateral triangle where all the sides are 2. So starting point. Now I'm going to, because all the sides are 2, all these angles are the same, because it's an equilateral triangle, the angles are the same, and they're all 60 degrees, which is the same as pi on 3. Okay, I'm going to cut this in half. So I've cut it in half, so that's a right angle now. This bit here, well, it used to be 60 degrees, but now I've cut it in half, so it's 30 degrees. So that's 30 degrees, which equals pi on 6. Now I've cut this side length in half, so instead of being 2, it's now 1 along there. And this length along here, well, let's use Pythagoras again. Hypotenuse squared equals opposite squared plus adjacent squared. So the hypotenuse is 2, so 2 squared. Opposite, let's say that's the 1 side, plus adjacent squared. That's 4 equals 1 plus adjacent squared. Take 1 away, 3 equals adjacent squared. So the adjacent side is the square root of 3. This is square root of 3. Okay, so now I'll draw this again, make it a bit neater. Okay, right angle there. This one is 60 degrees, or pi on 3. This one is 30 degrees, or pi on 6. We've got 1, 2, root 3. So now we can say that sine of, let's do the 30 degrees one first, pi on 6. Opposite over hypotenuse, 1 over 2, half. Now cosine pi over 6, well, that's adjacent over hypotenuse, so that's root 3 on 2. And lastly, tan of pi on 6. Tan of pi on 6 is opposite 1 over adjacent, root 3, 1 on root 3. By the way, as a quick aside, aside from this one, is some people like to not put surds as the denominator. It's kind of a neatness thing. So what you can do is multiply this by root 3 on root 3, because root 3 on root 3 is 1. So if you multiply by 1, you're not doing anything. Then you get 1 times root 3, that's root 3, divided by root 3 times root 3 is 3. So you could call tan pi on 6 root 3 on 3, or you could just leave it as 1 on root 3. Either is fine. Okay, so that's our 30-degree angle. Next, let's look at our 60-degree angle. Sine of pi on 3, or 60 degrees, is, well, opposite root 3 on 2. And cosine of pi on 3. Pi on 3 cosine is adjacent 1 over hypotenuse 2, so that's a half. And tan of, pi on 3. Tan of pi on 3 is opposite over adjacent, so that's root 3 on 1. Root 3 on 1 equals root 3. There we go. We've found lots of exact values here. We've found all the exact values for our key angles. Okay, so if we scroll back up to our the key angles we were thinking about, the 30 degrees one, 45, so pi on 6, pi on 4, and pi on 3, 30, 45, and 60 degrees. We found the exact values for all of those using our clever triangles. Now, personally, I never remember all the exact values. That's too much to remember, all the exact values. All I remember is that to get some of them, I start off with a square, side length 1, cut it in half, cut it in half, and then look at that triangle. Second one, I look at equilateral triangle, side lengths 2, and cut it in half. Okay, if you just remember those starting points, you can find all the exact values without too much difficulty. Alright, that's it for this one on exact values. See you later.